Welcome to this session 1G to 5G, the evolution of mobile wireless technology. Before going to this session, we know since the last few years there has been a phenomenal growth in the wireless industry. Widespread wireless technologies, increasing variety of user-friendly and multimedia-enabled terminals, and wider availability of open source tools for content generation that has led encouraged user-centric networks, resulting in a need for efficient network design. Evolution of wireless access technology have formed different evolutionary paths, but with a common aim related to performance and efficiency. Let us see these evolutionary paths in detail. These are all the contents we are going to see in detail. Communication is the integral part of science which has been focused on exchanging information from one point to another. The term communication was first introduced after the discovery of telephones, which later replaced the telegrams and letters. Wireless communication is the fastest growing technology which became more significant after the arrival of 5G systems. The important key factors for the advancement of wireless communication is electromagnetic waves. In 1678, Huygens worked on the light reflection and refraction theory. Later in 1819, wired communication turns to wireless because of the wave nature of the light. Electron follows particle nature through a wired medium and wave nature in wireless medium. Thereby, EM waves, that is electromagnetic waves, comes into the picture. During 1831, Faraday proves electromagnetic induction, and wave equations were formulated by Maxwell at 1864. Hertz validates experimentally the broadcast and response of electromagnetic waves over a few meters apart. With this, the following establishments were made the wireless communications more popular across the globe. Marconi, an Italian inventor, transmitted Morse code signals using radio waves wirelessly to a distance of 3.2 kilometers in 1895. It was the first wireless transmission in the history of science. Since then, engineers and scientists were working on an efficient way to communicate using RF waves. Telephone became popular during the mid of 19th century due to wired connection and restricted mobility. Engineers started developing a device which does not require wired connection and transmit voice using radio waves. Why we use wireless communication? Because it has no wires. Wireless technology are differentiated on the basis of their range. Some offer connectivity within a few feet via Bluetooth and other cover medium-sized office space. The mobile phone covers whole continents. Wireless technology offers e-commerce more flexible and inexpensive ways to send and receive data. The four key benefits of wireless technology are increased efficiency, that is, high technology communication systems leads to faster transfer of information within business and between customers. And second one is rarely out of touch. No need to carry cables or adapters in order to access office networks. Third one, greater flexibility for users. Yes, wireless workers in the office can be networked without sitting at dedicated PCs. And fourth one, reduced cost. Wireless networks are mostly cheaper to install and maintain than wired networks. What is G? G stands for generation. In the last few decades, mobile wireless communication networks have experienced a remarkable change. While you connected to internet, the speed of your internet depends upon the signal strength that has been shown in alphabets like 1G, 2G, 3G, etc., which is present right next to the signal bar on your home screen. Each generation has some standards, different capacities, new techniques, and new features which differentiate it from the previous one and also which detail the technological implementation of a particular mobile phone system. Zero generation. Wireless telephone started with 0G, which became available after the Second World War. In those pre-cell days, mobile operator sets up the calls because there were only a handful of channels available. These mobiles does not support the handover feature, that is change of channel frequency. 0G refers to pre-cellular mobile telephone technology in 1970s. Radio telephones are mounted in cars before the advent of cell phones. Mobile radio telephonic system produced modern cellular mobile telephone technology. Since they were predecessors of first generation of cellular telephones, these systems are called zero generation systems. The technologies used in these systems included push to talk, mobile telephone system, improved mobile telephone services, advanced mobile telephone system, often like LAN mobile telephony, and mobile telephony system D. The primary users were loggers, construction foremen, and celebrities. They were used for them for basic voice communication. 0.5G. It is a group of technologies with improved features than the basic 0G technologies. These early mobile telephone systems can be distinguished from earlier closed radio telephone systems in that they were available as a commercial service that was a part of the public switched telephone network with their own telephone numbers rather than part of a closed network, such as police radio or taxi dispatch systems. These mobile telephones were usually mounted in cars or trucks, and briefcase models were also made. Typically, the transmitter receiver was mounted in the vehicle trunk and attached to the head. The head contains dial, display, and handset mounted near the driver's seat. Early examples for this technology are the ARP, that is, the auto radio pooling, launched in 1971 in Finland as the country's first public commercial mobile phone network. The second one is the B-Nets, launched in the year 1972 in Germany as the country's second public commercial mobile phone network. 1G. This is the first generation in the wireless telephone technology. It was the analog telecommunication standard which was introduced in 1980s and continued till the invention of 2G technology. This technology was used in the first wireless mobile phone handsets. It replaced 0G network as the mobile phone began to rise in popularity with general public. 1G technology was first used in Japan and spread quickly to the whole world. 1G technology used the analog radio signal. Though this network, the voice call gets modulated to a higher frequency of about 150 MHz, and this was done with the help of FDMA, that is frequency division multiple access. The maximum speed of 1G is 2.4 kbps. The 1G mobile phones used a single universal network standard which is known as Advanced Mobile Phone System, that is AMPS. The cell phone networks were intended for the industrial, military, and research application. They used a series of dissimilar networks with very small broadcast areas. The drawbacks of first generation are poor voice quality, poor battery life, large phone size, and has no security, only limited capacity, and poor handoff reliability. Second generation. 2G is the second generation wireless cell phones which based on digital technologies in the early 1990s. In 1991, 2G was launched in Finland. It provides services such as text message, picture message, and MMS. It has greater security for both sender and receiver, and all text messages are digitally encrypted, which allows for the transfer of data in such a way that only intended receiver can receive and read it. 2G system use digital mobile access technology such as TDMA and CDMA. TDMA divides signal in time slots while a CDMA allocates each user a special code to communicate over a multiplex physical channel. The different TDMA technologies are GSM, PDC, IDE, and IS-136. GSM was first used in 2G system, which is abbreviated as Group Special Mobile. CDMA technology is IS-95. GSM is most admired standard of all the mobile technologies used in more than 212 countries in the world. GSM standard makes international roaming very common between mobile phone operators, enabling subscribers to use their phones in many parts of the world. GSM uses TDMA to multiplex up to 8 calls per channel in the 900 and 1800 MHz bands. GSM cannot only deliver voice but also circuit switched data at speed up to 14.4 kilobit per second. The drawbacks of second generation are it requires strong digital signals and it unable to handle complex data such as videos. 2.5G, which stands for second and half generation. It is a cellular wireless technology developed in between 2G and 3G. It is used to describe the general packet radio services, that is GPRS. It provides the data rate from 56 kilobit per second to 115 kilobit per second. 2.5G networks may be supported services like web, SMS, MMS, mobile games, and well internet access. 2.75 generation. 2.5G networks advanced to enhanced data rates for GSM evolution, that is EDGE, links with the starter of 8 PSK encoding, but the symbol rate remained the same at 270.83 samples per second. Instead of 3 bits, each symbol carried in 1 bit. Enhanced data rates for GSM evolution. Enhanced GPRS or IMT single carrier, that is IMT-SC, is a regressive compatible digital mobile phone technology that allows improved data transmission rates as an extension on top of standard GSM. Third generation. 3G technology, usually referred as Universal Mobile Telecommunication Standard, that is UMTS, which is found to be 3 times better than GSM, so-called 3GSM with maximum data rate of 8 Mbps. It assigns low data rate channel for voice calls and large data rate channel for video calls. To frame the international standard for 3G cellular networks, International Telecommunication Union, that is ITU, signed the International Mobile Telecommunications 2000 in the year 1999. Thereby, the 3G was supported by two main technologies, UMTS and CDMA 2000, with the support of 3GPP and 3GPP2 respectively. UMTS uses the air interface as wideband CDMA, that is WCDMA, often called as Universal Terrestrial Radio Access UTRA. It is configured to support up to 2 Mbps data rate with frequency division duplexing, that is FDD, and time division duplexing TDD, whereas CDMA 2000 uses multiple narrow band CDMA carriers. It requires higher bandwidth that becomes the drawback of the technology. 3.5G technology. 3.5G, also termed as high-speed data packet access, that is HSDPA, which is 6 times faster than UMTS technology, thereby supporting data rate up to 14.4 Mbps. Next, 3.7G technology. A high-speed uplink packet access technology, HSUPA, is the version of UMTS and WCDMA. Uplink evolution technology. It drives the 3.75 generation technology beyond the application of 3G. It is established to boost the uplink data rate to 1.4 Mbps and later up to 5.8 Mbps. HSUPA has many applications with advanced data rate such as mobile email, real-time gaming, various business applications, etc. Next, 3.9G technology. Long-term evolution, that is LTE, is thought as a lead towards the 4G technology and hence named as 3.9G technology. It uses evolved UTRA, that is EUTRA, as the air interface, and it is supported by single carrier frequency division multiple access, that is SCFDMA, to achieve 50 megabit per second data rate at the uplink. In downlink, 100 megabit per second data rate is achieved through orthogonal frequency division multiple access, that is OFDMA. Fourth generation. Fourth generation of mobile technology offers a speed of 100 Mbps. It is established to incorporate the major requirements such as quality of service and data rate. This is done by small applications such as MMS, video chat, HDTV, digital video broadcasting, and wireless mobile broadband access. It is attracted by the property of interoperability between various networks. For a stationary user server, it provides 1 Gbps data rate, and for a moving user, it offers 1 to 100 Mbps data rate. OFDMA technique is a new method which is the combination of CDMA and IS-95, which is implemented in 4G by dividing the channel in narrow band to transmit data packets with greater efficiency. IEEE 802.16M and IEEE 802.16E developed the WMBA techniques to provide downlink data rate of 128 Mbps and uplink data rate of 58 Mbps. There are some major issues in 4G. One is position management and the other is handoff management. LTE and WiMAX are the driving forces of 4G technology, and these two are suffering by security issues to destroy data availability, integrity, confidentiality, and authentication. WiMAX is suffered by DOS attacks, replay attacks, key management, and reducing quality of service, whereas in LTE, DOS attack, data modification, and scrambling attack are the major issues. Fifth generation. The number of users is increasing very rapidly, and there is a necessity for simultaneous connections to be employed for the final users and the deployed sensors. To increase coverage, spectral efficiency, data rate, security, and signaling efficiency, and also to reduce latency, we must find a new technology beyond 4G, which is named as 5G technology, which supports FDD mode and TDD mode. Thus, 5G offers 1 Gbps data rate and allows us to experience a real wireless world wide web, that is WWW. It follows all IP model to provide interoperability between all networks and uses packet switching rather than circuit switching. As the technology grows, the requirement of spectrum increases significantly. 2G requires 8 times additional spectrum than 1G. Similarly, 3G requires 25 times that of 2G, and 4G needs 4 times more spectrum than 3G. 5G should support ultra high speed data that is 1 Gbps and ultra low latency, which is less than 1 ms. It requires a wide bandwidth which is not very easy to provide. Thus, 5G is revolutionized with cloud RAN or edge computing and network slicing. Frequency permitting and spectrum organization problems might have solved by the software defined radio link, that is SDR. Thereby, it can allow more than 100 channels simultaneously without streaming. The world of mobile wireless communication is rapidly developing. The last few years have experienced a remarkable growth in wireless industry. There are many new techniques and technologies that will be used in the new 5G cellular or mobile telecommunication system, and these new 5G technologies are still being developed. However, as the required technologies develop, they will be incorporated into the new system, which will be defined by the standard bodies over the coming years. 5G technology, which is the one makes us feel everything connected as real world with the very high data rate and capacity. The world is trying to become completely wireless, demanding uninterrupted access to information anytime and anywhere with better quality, high speed, increased bandwidth, and reduction in cost. Thank you.